Now we have a presentation by Catalina Espinoza from Chile. She's you are a computer scientist, but nowadays doing research in educational topics. And the thing what you are now describing is more related, I would say the content now is more related to textbooks, but the ideas or using this kind of method can be used in different kind of fields of education. You just think about how to use it and then you use it. So, Catalina, if you want to say something more, just...
Thanks, Joni. Do you hear me fine? Okay, thanks for coming. I'm Catalina, as Joni said. I'm going to talk to you about this project I'm working right now here in Jyväskyla. It's analyzing teacher speech using topic inferred by unsupervised modeling from textbooks. This is like the buzzword that group this topic is machine learning and big data. These are like the overall fields from here. So I'm going to try to tell you a little bit what I'm doing here. So Joni just presented me, but I wanted to tell you a bit more. I'm a research assistant at the Centro de Investigación Avanzada en Educación, CIAE, from University of Chile. You can send me an email with question, or if you are interested in this kind of research, we can send me an email to catalina.espinoza@ciae.uchile.cl. So I'm in this center of educational research, and as Joni said, I'm a computer scientist. So coming here and present to you is really like an amazing opportunity to me to get feedback from the educational part of this project. So any question, any comment, any suggestion is really welcome. Because, as I said, I have my perspective from computer science. So, a little bit about the project. The work I'm going to show you today is framed in this project called Smart Speech. It's a collaboration between the Chilean Research Center CIAE and also Jyväskylä University and also Tampere University. You can see some of the names of the collaborators. Across time have been more researchers in the project, but this is the current state, at least for the part I'm showing you today. So what's the Smart Speech project about? So we are working in this application, a Smart Speech app. The goal of this app is to record information of classroom sessions and get, for example, the audio recordings or observations from classroom sessions, and work with this data and try to get some good visualizations and some good metrics of how these lessons, So this app currently has two modules. One module is from a teacher module where the teachers can record the session, and has this other module for observation. So observers who are going to lessons can use different protocols to observe lessons, and this way we can gather data from classroom lessons, and we can try to do some research, and also hopefully we can provide a good feedback for teachers. So I'm going to talk a little bit more of the teacher module. The teacher module essentially just record the audio of the sessions, and with this data we send it to our service of automatic speech recognition service, so we can take the transcriptions of the lessons, and then we can do some analysis with that data. So I wanted to say that we're working only with the audio records, and we are using only the speech, the teacher speech. We are not recording currently students, and there are several reasons for that, because one is privacy matters, and also because it's way more difficult. So we're working right now with teacher discourse. So another thing is that we are using automatic speech recognition system, and the idea here is the whole process to be automatic. So we want to capture features from lessons, but we want this process to be automatic. And this is because traditional observation methods are really time-consuming, expensive, and it's difficult to scale them. So we want to build these automatic methods in order to not to get rid of traditional methods, but to complement them in a way that all the human resource can be put it in the places that matter the most. So it's more, it has to do with efficiency with the resources. So after we gather the audio records and we got the transcription from the server, then the idea of the app is that we can send a feedback to the teacher. So the feedback has to be in a format that is useful to the teacher, and we also want to be useful for research, to have an idea of what is happening in the lessons, and compare different lessons. That's the thing. With an application, we can record lessons from different teachers, different classrooms, from different grades, contents. So if we gather enough data, we can compare even lessons among countries. So in the scalable characteristic of this project is really nice, because with the same tool we can use the same tool in lots of contexts. So when I say feedback, I meant visualizations, and this is an example of what in the project, in the Smart Speech project, we have been doing. So there is a paper from Helakowski and Viri here. So in this paper, they describe how the lessons can be represented as in a graph manner. So if you create graph of how the teacher is connecting the concept during the lesson, those connections, they found that are really correlated with the learning gains of the student. So in a way, how the network of the concept looks can tell you, well, it's a bit too much, but it's really correlated to the posterior learning gains of students. So this is an example of what a meaningful visualization is. So the second paper that is here is Caballero and collaborators. So in that paper from last year, it's exposed how, because the first paper is the methodology is by hand, so it's not an automatic task. And the second paper describes how can we get some really similar results with these automatic tools. So it can be done. So what we're doing right now is gathering transcriptions, because as I said in the beginning, this aims to be a big data project, so we want to gather all the transcriptions that we can, and we hopefully we can build some meaningful tools with that data. that was the context of the project. Now I'm gonna speak of what I have been doing here these past 2 weeks. I didn't say I'm a visitor here. I have been for 2 weeks, and I'm gonna be 1 more week. So I feel like I'm leaving Jyväskylä, but it has been a great time. So what I'm doing here is replicate somehow what we have been doing with Chilean lessons, but here in Finland with Finnish lessons. So what we did in Santiago was take a bunch of school textbooks, use that data to train an unsupervised topic model, and with that model we described classroom lessons. So here I'm doing the same, well, not just so not just me, we're a whole team. We're doing the same with Finnish textbook, and then we are describing Finnish lessons. So actually this picture is a bunch of pages that we just cut from textbooks to scan them and take the data. So this is real. Okay, so what's the process behind this from textbooks to lessons? Here is a description, a really modular description of what we are doing to analyze classroom sessions. So each box represents a part of the process, and it has a description of each of that part. And it doesn't matter that you don't get right now the idea of what the box is about. I'm going to describe each step during this presentation. So the first step is just extracting the text in a digital format from the textbooks. Then we pre-process the pages. This means cleaning the data. Then we train the model, the topic model we are using. In parallel, we pre-process the transcription from classroom lessons in the exact same way that we pre-process pages from textbooks. And when we have all that data pre-processed and the model already trained, then we use the model, we use the classroom, and we try to describe the classroom with the model. That's the whole process, and this is what I'm going to talk about in the next slides. So first, extract the text from textbook pages. We collected 8 school textbooks, different content and exercise, and we use different formats. So we had some textbooks in PDF, Word documents, and also images that we take like the real textbooks and we cut them. And then we, using OCR, text recognition from images, we take the text from textbooks and we work with that text as pages. So each page of the textbook, we consider it a document. And this is an important thing, so keep it in mind, because for training the LDA model, the unsupervised modeling that we're going to use, we have to have a unity of text. And in our case, it's going to be a textbook page. So there are going to be assumptions regarding that unity. That is a textbook page. So we extracted around 2,000, and well, the same thing I just said, we consider each page as an individual document. The second step is pre-process the pages. So this is really straightforward, not straightforward, it's more like these steps are really common when working with data and data mining. Yes, that was the word I want. So first, a general cleaning. This is removing symbols when the algorithm that takes take the text from the textbook, get some mistake. So general cleaning, removing stop words. I don't know if you're familiar with the term, but stop words are the words that in a language doesn't add meaning to the text. So for example, I don't know, like several others. So this depends, of course, in the language that we're using. So in this case, Finnish, we use Finnish stop word. We also detect names in the textbook. So every time a Finnish name appears in the textbook, we put a label. So it's not gonna be Joni anymore. It's gonna be a name, and it will be the same word for every name. So we also do the same with the numbers. So there are lots of numbers in the data we have. So we just use a unique label number. We remove and replace some symbols, and we are trying with the stemming. In the results I'm going to show you today, it's not really, we didn't do it, but stemming is a common preprocessing step that is taking the root of the words. So when we work with the text, we are not working with words anymore, we're working with the roots. So this can help us to group words that are related. But in this result, I didn't use it, so it's with this question mark. So the third step is training the unsupervised topic model. So this is when the fun begins. We're using a Latent Dirichlet allocation model. LDA was published in 2003 by Blay, Ng, and Jordan. This is a common known, is a commonly used topic model, maybe the most common. What it does is infer topics from a corpus of documents. So we have a set of documents, and LDA, what it's going to do is to infer the topics of that bunch of documents that we use to train them. So what are topics? Topics are groups of words. Generally, topics are groups of words that occur together. That's all. For LDA, topics are probability distributions over a dictionary. So even if in like common quotidian daily life language we use topic to refer groups of words that are related, in the model the topics are the whole dictionary, the whole vocabulary present in the text with a probability distribution over that vocabulary. So we're going to have topics that concentrate the importance of that regarding that topic in a few words. For example, education, the topic education, will have all the words in the vocabulary, but the most important words to that topic are going to be students, school, teachers, and so on, so on. So that's what topics are. So a special characteristic of LDA is that documents are bag of words. This means that the order in the document doesn't matter. The words are just, you take the whole document, in our case the text page, and the order doesn't matter. So that's a big assumption, but we're going to see that it's okay. So documents, and this is the distinctive characteristic of LDA. Documents are described by a mix of topics. So there are other topic models, but we use LDA because of these characteristics. So we want to describe classroom lessons, but we don't want to label the classroom lessons only by one topic. We want to label the classroom lessons with several topics, and we want to understand what's the proportion of different topics in a classroom lesson. So that's why we're using LDA model. Okay, so how does it look, an LDA model? So we train an LDA model with 30 topics. We have to tell the model how many topics we want to infer from the textbook pages. Yes. So this is just an example of the top 10 words from 5 different topics. So I don't understand Finnish, so hopefully you can tell that those topics seems like related words. And you may also tell that it's not perfect. Some words doesn't make that much sense, and that's fine because topics are not a group of semantic related words, are more words that occur together a lot. So this is how 5 topics from the LDA model that we train look like. So I can recognize some of the words. For example, this I think is mobility or velocity, something like that. Yeah? Yes? Okay. This is time. Yes. I need some feedback. Okay, this G is acceleration, gravity acceleration. So I guess here are other force-related words. This is battery. So this is like an electric topic, and these are light-related words. So maybe you don't all know Finnish, as I, but these are topics, and these are the topics that we are working with. So the next step, and this is a parallel step, we pre-process transcriptions from classroom sessions in the same way we pre-processed textbook pages. So if you paid attention to the step 2, it's exactly the same list of steps because we are using the same methods to pre-process the data in the same way in order to both the textbook documents and the classroom sessions are in the same format. So it's exactly the same. And now we are back to the general pipeline. Hopefully you understand all the steps I described already. And now it comes the time to explain you how do we use the LDA model and work with the transcriptions in order to get a meaningful description of the classroom lessons. So what can we do with the LDA model? LDA model here, this paralelepípedo in Spanish, this figure represents the instance of the LDA model using the Gensim library. That's the Python library that we're using to train the LDA model. So this instance has different methods that we can ask the model to get some output. So what we can use, for example, one of the things that we can do is give the model a text document. That now I'm not meaning a textbook page, I mean any document. So it can be just a sentence, it can be 10 minutes of a lesson, or it can be a complete lesson. So I give this text document to the model, and then I will get a topic distribution, a probability distribution over the topics. So any text, I can from any text I can have a probability distribution over the topics. So that's what we are doing here. And what does it look like? So here in this figure, I'm showing you we have 2 lessons, 2 classroom lessons, and we here it's plotted the probability distribution over topics for these 2 lessons. So these are different lessons, although it doesn't appear to be because it looks really similar. So we have this blue lesson and orange lesson, and the shape of the curve is quite similar. So I just got these 2 files with different names, and I put it in the LDA model, and I got this topic distribution. And as I don't understand any Finnish, to me was something happened because it shouldn't look like this. If those are different lessons, then a topic, there must be some difference. And it actually, there are some difference, like little difference. You can tell that the points are not in the exact same places, but look quite similar. So when I asked what were these lessons about, well, these two lessons were about the same content, same grade, same teacher, and actually was one class before the other. So it made sense that these two curves were really, really similar. So I recover. Yes. So I'm showing you now the probability distribution over topics, but you might be asking yourself, what are those topics about? So what is topic 6 about that is so important in both lessons? What is topic 13 about? And so on, so on. So here I'm showing you, these are not the exact topics, these are the words that activate these topics in lesson 1. So if someone who understands Finnish can help me, because can you tell what are these topics about? No? Okay. Topic 6. Okay, so I guess none of you speak Finnish as me neither. So I'm gonna try to recall what, because when I did this, I used a lot Google Translate to understand what this topic were about. So, what? Sorry. Okay.
6 is like connecting words, for example, a lot.
Okay. Okay, that's really helpful. So she said that topic 6 are connecting words. So when we go back to this and we see that topic 6 is the most important in both lessons, then it kind of makes sense that the connecting words are the most important in those two lessons. It wasn't, for example, in Chile, we didn't get this result. So to me, it was a surprise. But it makes sense. Are words that are present in the lessons, in every lesson, so okay. And topic 13, this I really know what it's about. It's about electricity. I don't know each word, but as I said before, Pariston is batteries, and well, that's again. This is electricity, maybe, or voltage, I think. Janet, so do you see when I point with the mouse? No. Oh, that was, you didn't get. So I'm trying to, here? No. Okay. So first word in topic 13. Janet? Voltage. Thanks, Joni. So it's voltage. So you will have to believe me that every word in that topic, or more or less every word in that topic, is about electricity. So that was the second most important topic. Okay, so we also have this kind of topic that are not so, that are more ambiguous. So not every topic is really understandable, but some of they are. And if we use this as a descriptor of the lesson, we can compare lessons. That's the thing. So we can tell from this that this session is about electricity, and we can have a quantitative unit that tells us how much how much this session was about electricity, and then we can compare this session between with others. So, for example, here we're comparing 2 sessions of electricity, but we can compare it with a session of dynamics, kinematics, whatever, and we can have an idea of how different the sessions are. So that's the goal. So here is the same. We plot words that activate topic in lesson 2. So you can tell that it's not the same words for every topic. So the lessons are actually different from each other, but the same topics are being activated. So it's not exactly the same for both lessons. So this, what I have showed you, is what I have been doing here. We want to apply this to more sessions. We are already pre-processing around 30 lessons, so we can, in the future, not now, we can show you how can we compare different lessons from different teachers and different contents and different grades. But as I don't have finished results with finished lessons, I'm going to show you a little bit of what in Santiago we have been doing with this method. So here is an example of a lesson of 10th grade about uniformly accelerated motion. So here is the time series of the co-occurrence strength between different topics. So the red line, for example, is the content and math skills relations. So we can have an idea of the strength of the relation between topics of content and math skills. So if we have this time series, this description can tell us, for example, there is a part of the session that has somehow a valley. So we can ask ourselves, what happened in that valley? Why do we have this huge peak at the first of the session and then a peak in the second part of the session, but why do we have this valley in between? And this is what I meant at the first, when I was starting the presentation, is that we can use this method to focus the resources of traditional methods. So if we're using traditional methods, all the lessons are going to look the same for us. All the whole session are going to look the same for us. But if we use this kind of method, we can focus our questions in the parts of the lessons that look different or call our attention somehow. So we can describe one session in like a time series, and we can compare this time series with different lessons. So here probably you can like see exactly what is the number of each line, but what I'm trying to say with this slide is that every lesson is different. Okay, we know that, but how different? We can have, this to me is like an ECG of the lesson. So we can have these descriptors of what is happening in the lesson, and we can compare different lessons. Maybe if we have lots of 12th grade light lessons, then we can tell when something is odd. Like, okay, I know how a 12th grade light lesson looks like, and then I have this completely different time series shape. So I can now, in the same way, I can focus the resources in analyze what is happening in this odd shape lesson. So those are the ideas behind of visualizing the lessons in this way. This is a different kind of visualization we're working with. So here we're not plotting the complete lesson. We're representing each session is represented by this circle, this ball. So each ball is a session, and the color of the circle is the grade of the session. So we can compare now different sessions, and we can plot those sessions in this space that is telling us how much these sessions are relating content. So each axis in this visualization represents the strength of the relations in the lessons between different topics. So when we put the lessons in this space, we can have this, again, is the same idea. So we can tell, for example, this 8th grade session is in the corner, in the more far away corner. This means that this session is really, has a really strong relation between different topics. And it's kind of odd because this is an 8th grade session, and the red ones, for example, are 12th grade sessions. So we can ask ourselves, okay, this is an 8th grade session. Why does this session relate the content in such a strong way that even related words in a more strong way than 12th grade sessions? So what happened in this classroom session? So we can start asking ourselves questions that we didn't have the opportunity to ask before, when we have like only the audio recordings. Okay. So in summary, what are we doing? We are describing classroom sessions using topics extracted from textbooks. That's what we're doing. We want to be able to compare sessions from different content, levels, teachers, and even countries. I didn't mention, but it's in one of our goals is to compare what does it look like a Finnish lesson with a Chilean lesson. For example, if we had data, the interesting thing is that with this same pipeline that I show you today, we can apply it with every language. So we can compare lessons from different countries. It doesn't matter. If we can translate all the lessons into the same language, then we just apply the same process and we can compare different lessons from different countries. So, and we are looking for visualizations that are useful to teachers and researchers. So to me, this is one of the most important things because as I'm a computer engineer, I want to be part of projects that develop things that are useful. So, and that's why I'm really glad to be here in this educational environment, because now that you know what we have been doing, you can suggest me and ask questions and everything that can help us to know what would be useful. What can we do with this that is useful for teachers and researchers? Yes. So thanks. That was my presentation. Thank you very much. Any questions?
Questions, comments? Please speak loud.
Every single language is ready for English, Finnish, I guess.
Yes.
How are you going to deal with how the system will be?
Yes. Yes, it's a really good question because she asked if this is ready for applying it to different languages. And the answer is right now, no, it's not ready. It's just ready for Chilean, like Spanish, yes, and Finnish. But as I said during the presentation, we are thinking about how are we gonna modify this process in order to be able to compare different lessons from different countries, specifically different languages. And it's not that difficult. So it's not, even if I'm telling you like it's not ready, it's not something that it will take that much time, because we are trying to do everything in the most automatical way. So if we can, for example, translate everything to English, then of course it won't be as accurate as working in the language that the original language, but hopefully we can have a good baseline, like a good result. Yeah.
With both general language and specialized language terminology and general.
I'm not sure.
Like we're talking about electricity. All the words related to electricity, we can call them terms, for instance, and the words. We're also working with words in general language.
No. I don't know if when you said general language, you mean like oral language?
Since we were talking earlier about, for instance,
Okay.
specialized, like we're talking about the terms and events. Terms, they are the words that are used.
Okay. Okay, so she asked me if we are treating words that are more content specific, different from words that are more general. And the answer is no, we don't treat any word different except that the ones I told you, that was names, general names in both Spanish and Finnish, and also numbers. And yeah, here is there is an asterisk that we are trying to group some words like explanation words. We are trying to group them all together, but right now, no, that's all. And only the LDA model is the one that it's able to it's not distinguished, but the most two words occur together that then are more probable to be in the top of the topic, and that's all. Yes, no discrimination. I saw a question about, no? Okay.
I'm just checking if I understood the model.
It's okay.
So you guys assess the frequency of the usage of certain words in a class, and then you try to analyze the lesson. Is that how it works?
Not really. So could you explain a bit more?
Analyze the frequency of occurrence of certain words related to a topic, and then you try to see if the lesson went well or not.
Okay. So I'm gonna repeat. I don't know if everyone heard what she said. Okay, she said that if what we did, she's checking if it's okay. So she's asking if what we did was checking the frequency of the words that are already assigned to topics, and then we check if the lesson was good or not good. Yes. Okay. I have like several things to say about that, so I'm gonna go back a little bit on the slides. So here, for the steps 1, 2, 3, and 4, we don't check any word frequency, nothing. Okay. No frequency. Everything that's related to group the words into topics is in this step, and it doesn't do a specific word frequency, use other forms. So here, what I described were different things. Here, in this kind of description, we don't use word frequency, but here, I think that's what you meant, we do. So yes, I didn't say that, but it's true. What we did was take all the topics related to each word, and then we count how much that topic appear in in each sentence. So it's correct that was what we did. We use word frequency, but we could use other tools to work with the topics. So it's not necessarily the only way to go with these topic descriptions. Yes?
Has this model been tested in actual classrooms?
What do you mean?
Like have teachers and educators use this in a real life setting?
Okay, so it's this what I have shown you. No, so it's not when I show you the project, the application, the non-teacher is receiving these descriptors of lessons. No, that's not happening right now. What do you mean? Like right now, the smart speech application is being used by teachers to record lessons, and it has also been used because, as I told you, the application has 2 modules. So one module is for teacher recording, and that has been tested and it's an ongoing process. So we are still working, and it's not ready to release it yet, but it has been tested. And also the other module, yes. Okay. Any other question? No? Yeah. Sorry.
We go back to one slide.
This one?
Okay.
Sorry, I don't hear you. How to? Yeah, okay, so she asked how do I calculate the importance of the topic in each lesson? So, yes, I didn't explain that. It's not like I'm word frequency, I'm not doing anything of that. I'm just using the LDA model. So I give the text, and the model infers a topic distribution. This is like, I didn't talk about this, but the topic model infers a topic distribution over the document, and then assigns each word a topic, and then calculates the proportion of the topics in the lessons. So this importance is the proportion of the topics in the lesson. So all these are probability distribution. All these importance sum 1. Yes, does that answer your question? Yeah, exactly. Yes. Yeah, that's a good question. So we're working, this whole talk was about working with textbooks to describe classroom lessons, and she's asking what do we do with images, for instance. So some textbooks are full of images, and do we work with that? No. Right now, no. And we could. So there are other algorithms that describe, as Facebook, I suppose you have seen that Facebook sometimes describe images with words, so we could try to do something like that, like to label the images that appear in there. But I think that's not necessary, because usually textbooks somehow explain what the image is showing. So we have that text. So
Written texts only?
no, we have different editions of different textbooks right now. I don't recall the exact names, but if you are interested, I can give you the list of the textbooks we're working. Yes, just written text, yes. I think we are done. So thank you very much for, yes, thank you very much.